Hi, I am glad to be back with another video from SQLmaestros.com, and this time the subject is statistics. It is a huge subject, so I plan to record a series of videos around this subject, but let me get started with the basics first. So this is part 1, and of course there are going to be multiple parts to it. We will straight jump into action. So let me switch on to the VM. Now, first, before I begin with any demo, let me just quickly tell you something about statistics, what exactly they are. Statistics is an object inside SQL Server, and that object contains a lot of data. And in simple terms, it is data about the data. When you submit a query to SQL Server and the optimizer generates an execution plan and then executes that plan and sends the output to you, one thing that happens inside that black box, the optimizer, is that execution plan, and that execution plan is heavily dependent on statistics. You always want a great execution plan, an efficient execution plan, so that your data is returned as fast as possible. And statistics play a very important role here. What exactly statistics do? The execution plan is actually comprised of multiple operators, or more technically speaking, iterators, and each iterator has to deal with number of rows. So if the optimizer knows the estimated number of rows that it has to deal with the optimizer can actually choose the right iterator, and in turn choose the most efficient execution plan. To know the estimated number of rows, it depends on statistics, and this is what we call as cardinality estimation, which is estimated number of rows versus actual number of rows. So statistics play a very important role here. Of course, SQL Server can work without statistics also, but in that case, as you can understand, the execution plan is just going to be a default plan based on some guesstimates, and that might not be really good for your query. So let's get started with this simple demo to understand the basics of how statistics work. I'm using this database, AdventureWorks 2012, and there is a table here called person.person. I create a copy of it as person.person2. When I select from this particular table, and I will also turn on actual execution plan wherever needed. When I run this, I'm just simply doing a select star from this table. I'm trying to get all the records. Now, when you tell the optimizer that you need all the data, then the optimizer really need not bother, because there just could be one single way of how you can get all the data. Just scan all the pages and send the output to the client. When I run this, and when I look at SP help stats, which let me find out if there are any statistics on this particular table, when I run this, I can see that this object does not have any statistics or indexes, as I said, simply because I ran select star from person.person2. But the moment I tell SQL Server that, give me all the data where last name is equal to Bansal, and when I execute this, of course I don't have any record here which is equivalent to Bansal as last name, but something has happened behind the scene. If I go and look into the help stats system stored procedure, I can see that SQL Server has now created a statistics object on last name, and it did that before executing the query. Why? Because it actually wanted to estimate how many matching records could be there for last name equals to Bansal. So you could see, in order for SQL Server to generate an efficient execution plan, it is dependent on statistics. And if the right statistics object does not exist, SQL Server tends to create one automatically. Now, automatic creation, automatic updation is something that I want to talk about in this video. So let me just drop this object back again and run this again from scratch. So I have dropped this table, and I'm creating this again once more. And now let's scroll down further and get started. So first thing, I will show you that no object statistics object exists, so it's all blank. And apart from SP help stats, I think starting from 2012 onwards, Microsoft SQL team introduced another DMV called DMDB stats properties, and if you join this DMV with the system catalog stats, you can get little more detailed and meaningful information about stats. So I can see that right now I have nothing with person2. Now, Just a few seconds before, you saw that when I ran the query with last name equals to Bansal, SQL Server automatically created statistics. That happened because auto create stats database property was turned on, and that's the default. If I turn this off, let me do that. If I turn this off and then I execute this query, which I say select star from person2, and I put my predicate on 3 columns, first name, middle name, and last name, and I run this, I get that one record which matches the criteria. And when I look into the execution plan, you can see it's a table scan, which is good. But when you look at SP help stats now, you can see that SQL Server has not created any stat objects simply because we turned off auto create statistics. Likewise, if I look at this DMV and join it with the system catalog sys.stats, I can see that there are no objects. And going forward, I'm going to use this particular query. I won't use SP help stats, just to call that out. Now, let me turn on auto create stats. So when I turn this on, and remember, SQL Server, I need to show you one more thing before I turn this on. If I go to table, so I did not turn this on, so let me run this again. Okay, when I run this and I go into the execution plan, you saw that there was a table scan, and when I take my cursor over this, first thing you will notice that there is a small warning symbol here. And of course, whenever you get such warning symbols in the execution plan, it is advisable that you go and look into it. And the warning here says that column with no statistics, and this is very important whenever you're doing query tuning, and if you have columns without statistics and the optimizer is doing some filter on those columns, it is calling it out that you got to have statistics on these columns, which are at the moment missing. So that's one of the warnings. But apart from the warning, what I also want to show you that if I take the cursor over the arrow there, I see actual number of rows as 1 and estimated number of rows as 775. Now this is what I mean by cardinality estimation, which is estimated number of rows is 775 and actual number of rows is 1. So this 775 is a default guesswork by the optimizer, and there's a big difference between 775 and 1, and that's because there are no stats, so optimizer definitely does not have any data to do any computation on, which is where things are going bad. Now I will turn on auto create stats. Let me turn it on, and then when I run this query again, of course I get that one record which matches the criteria. But when you look into the execution plan, the first thing you will notice is now you get a different plan altogether. You get a table scan, but you also get parallelism, which is where the optimizer has chosen an efficient plan based on statistics. Now statistics do exist. Before I show you the stats object, let me take the cursor over the arrow and show you the cardinality estimation. Now you can clearly see that actual number of rows is 1 and estimated number of rows is 1. So statistics here is doing an awesome job, and cardinality estimation is perfect. You may or may not always find a perfect cardinality estimation because stats at end of the day help with approximate value, and they may not be always 100% accurate. I mean, that's how mathematics and stats as a subject go. When you look at the stats object now, let's go and look into the stats object, and you can see that 3 statistics objects are created. Now this is really interesting because you had one query, but you have 3 stats object, and I'm sure you have by this time figured out that 3 stats objects are created because your filter you were filtering on first name, middle name, and last name. So you had 3 columns there, and there is one stats object for each column respectively. If you look into the SP help stats, you can see the keys there. So first name, middle name, and last name. This also brings us to a very important thing to note here, that SQL Server can automatically only create single column statistics. It cannot or does not create multi-column statistics. If you want multi-column statistics, either you can create them on your own with create stats statement, or when you create a multi-column index, so SQL Server to support that index would create multi-column statistics. Now because these stat objects were created automatically. The engine SQL Server has given some system names to it, so you could see WA says triple some 5 6 7. Look at the order there, and some hexadecimal value. So this is an auto generated name. 5 6 7 here represent the ordinal number of the column, so this is 5th column, 6th column, and 7th column. And this is 5090EFD7 is actually the hexadecimal value of the object ID. And sys of course stands for system generated stats, and WA, as some people say, stands for Washington. I don't know how true that is. Anyway, now you could always verify that. So if I do a select star from person.person2, you can see 1 2 3 4 5. So 5th column first name, 6th column, and 7th column. What's the object ID for person.person2? Okay, it's 1351. So if I just simply go and take the calculator and I will type 13516758863, and we do a hex of that, 5090EFD7. Well, 5090EFD7, that's precisely was the hexadecimal value, and you can tally that. Sorry there. Yeah. So that's how you could decode the stats named there, but that's not very important. You need to understand how stats work and how important they are. Okay, so that's how you could see about the creation of stats. So let me quickly summarize. You should ensure that auto create stats is turned on. It's a best practice unless you have some very good reasons to turn them off. But in most typical SQL Server deployments, you will find that auto create stats is turned on, and when they are on, SQL Server will automatically create statistics whenever the optimizer has a need of one, and it can automatically only create single column statistics. Now I am not talking about indexes and stats behind the indexes, etc., and that's why I said we can have multiple parts to this video. Let me quickly talk about updating statistics now. So as you know, once the stats get created, and note that the stat object gets created before generating the plan, because the optimizer of course needs the statistics data to create the plan. And now over a period of time, of course, the data can change. So when the data changes, SQL Server has to go and update the statistics, but SQL would not just update the stats object every time and any time. There is a very simple formula there. 20% of the data needs to change. 20% plus 500 rows. That's a basic formula that has been put into the engine. There are many caveats to it, some trace flags, some new improvements and enhancements, and in some latest versions of SQL Server. I'm not discussing that right now in this video, so I'm sticking with that basic principle of 20% plus 500 rows that need to change before SQL Server can automatically update the statistics object. So if I select from this table, I can see that the total number of rows is 19972. You can look at the right corner there. Okay, so that's 19,972 rows, and if I do a 20% plus 500 of that, I get close to 4494. So let's say 4,500 rows. So if I have in total 4,500 rows changing in my table, then stats is going to be updated automatically. Now before I show you a quick demonstration of how stats are going to be updated, let's go and look into the stats object once more and focus on some important columns out there. So you know, 3 stats objects were created. This is the time when they were last updated. So in fact they were never updated, they were only created once as part of my demo here, and you can see all of them almost has the same time, which is 8th hour, 29 minute 47, and then some milliseconds out there. Now you can see there is a column here called modifications, which means after this these stats objects were created, we did not do any modifications, which means no data in any of these 3 columns has changed, so the modification counter stands at 0. Now we discussed that we need to have at least 4,500 rows to be changing. Let me just go back and run this again to get the number, which is 4494. At minimum you need this. So just to play around with this, I am trying to update now all the records not all the records, 4490 records, because business entity ID, as I have seen, the data is a serial integer of 1 and goes all the way to 19,000 something. So I'm trying to update 4,490 records, which is just slightly less than 20%. So when I do this update, I see 3685 rows changing, actually not 4490, which means not enough data, but any which ways. And then when I run the stats object DMV query, I can see that 3685 rows have been modified. So that's the modification counter. Now remember, this modification counter is actually based on the column data, which is one of the column data has changed, which is first name, right? So this is this one. Now you will notice that a fourth statistics object has been created, and by this time you would have understood why that has happened. It has happened because of this first column, which is, if you see, look at 1 here, which is because you ran this query, which was based on business entity ID. So now that your query has a predicate, a filter on business entity ID, SQL Server automatically creates a stats object for this. So let's continue with 3685, but you actually need 4500 rows. So I really need to update a few more rows. So now what I will do is I am simply going to run my query. Where is my query, by the way? Yeah, this is the one. So if I simply run this query, I mean, you don't get any output because I changed everything to last name as Bansal, but after you run the query and you look at the stats object again, and you can see absolutely no change. The stats timing, if you see, 08 29 47 is still the same. Stats objects have not been updated. So you really got to have 20% plus 500 rows. That needs to change. So what I can do is just manually update, maybe let's say another 1000 rows. Okay, and we will fire, and let me change this to, let's say, Amit 2, and we execute this. Another 645 is not going to be good enough, so I will change this to Amit 3, another few modifications. That sounds good. Now how many rows have we changed? So let's go and look at the stats object. In total 4975 is good, looks like. So if I just put 4975 here, is it more than 20%? 4975 of 19,772, that's a good 25% of the data that has changed. Good enough for stats to update stats to kick in. Now the most important thing to note here is 25% of the data has already changed, but stats object has not been updated. So you can see that the last updated time is still 8/29/47. It has not been updated. Now this is where many SQL Server professionals have confusion that, my data has changed and it has more than 20%, 30% or 40%, but stats objects are still not updated. Well, the stat objects will be updated only if the optimizer needs that particular column again, or that particular column is encountered again in any given query, which means until and unless I don't run this again, or I think whichever column was it, first name, until and unless I don't use first name in any of the query, the stats objects are not going to be updated. Now when I run this query, what SQL Server will do, SQL Server will hit this particular column and it will see that the modification counter is more than 20% plus 500 records. It's going to update the statistics, and then with the updated stats data, it's going to generate an execution plan. So when I execute this, I just pressed F5, I executed this, and you can see, okay, no data, that's fine. But now when you look at the stats object, execute, and now you can see that it's all back to 0 because stats has been updated, and this one got updated, which was our column number 5, first name, and you can see its time. Now it's 8:41:02, and the others are whatever they are, 8:41. So this is how you see that automatic. Now just like this property that we had, which is auto create stats, we have auto update stats, and that is also turned on. Oops, sorry, what's wrong? Yeah, auto update stats. So this is also turned on by default. So both auto create stats and auto update stats are turned on by default, and it's a best practice to keep them turned on. But in a couple of SQL Server deployments, I have seen that auto update stats is turned off because some DBAs tend to update stats manually using some maintenance plans or weekly or daily or bi-weekly scripts, which is fine. You know your environment best how to deal with it. But in this video, I just wanted to show you how the basics of statistics, how they're created and how they are updated. Do I have anything more? Okay, not much. Let me jump back to the presentation. Well, so I hope this demo was useful, and the intention was to just do quick basics about SQL Server statistics. Thank you very much for your time. I hope this video was useful in your learning endeavors. I'm available on Twitter at @a_Bansal. Do follow me there and hope to connect with you in next video. Thank you very much and you have a great day.